So today's 5.1. In your algebra book, we're going to be multiplying algebraic fractions. So your big idea, algebraic fractions are multiplied in the same way you multiply numeric fractions. So numeric fractions are just fractions with numbers like you're used to. So algebraic fractions are just a fraction that have variables in it. So two properties that we're going to be using today, your multiplying fractions property, a over b times c over d equals, straight across, a times c over b times d, just like numbers. Okay, so multiplying the variables is just like multiplying numbers. And our equal fractions property, a over b, is the same as a times k over b times k. So that one looks a little weird. That's like saying 3 over 5 is equal to 3 times 10 and 5 times 10. Okay, so a and b are 3 and 5, and then k is 10, because we know that if we had 30 and 50, which is the product of these two, 30 over 50 is equivalent to 3 over 5. So as long as you multiply the top and bottom by the same number, you can also reduce it and divide by the same number, that those are equivalent. One's further simplified, but these two fractions are equivalent to each other, or equal fractions. Okay, so we're going to kind of jump right in. Today's all about being able to deal with some variables in our fractions, and then the bigger idea is knowing how to simplify with all of these fractions. So we're going to talk about a couple different strategies that we can use to make this super simple. I think you'll like this unit. It's pretty straightforward. Once you get the hang of it, it's pretty easy and actually kind of fun. So multiplying, starting with the basics. So if we just have numbers, we're multiplying straight across. Now, if we're going to use this rule for a second, I want to rewrite this. I know we all can just say 3 and 8. But rewrite it so it helps us a little bit when we get to deal with the variables of what this actually says. So if I want to rewrite this as just one fraction instead of 2 being multiplied, the numerator is 1 times 3, and the denominator is 2 times 4. And so I can simplify that. It's 3 on top, it's 8 on the bottom. Okay, so it's equivalent to 3/8. So if I want to use those same rules here, one big fraction, I'm multiplying x times 3 on the top, and I'm multiplying 2 times 4 on the bottom. So on the top, x times 3, we always put the coefficient first. That's 3x. And on the bottom is 8. And that's a perfectly good answer. So you can see the similarities here. We've just put the variable in, but the coefficient of the variable is a 1, just like this 1. And so it's going to be similar, except we just have that x in our answer. So what about up here? We're doing 2x times 3x over 5 times 7. So let's start with the bottom. We know it's 35. We can multiply these two together. 2 times 3 is 6. And now we haven't really talked about what's x times x. What is x times x? We know if we add 2x and 3x, it's just 5x. So if we multiply 2x and 3x, is it 6x? It's actually no. So an x times x is actually x squared. We're not going to get too deep into that. We will later on. But right now we need to know if you multiply 2 x's together, it's x squared. If you were multiplying 3 x's together, it would be x to the 3rd power. So basically count how many x's you're multiplying, and that's what your exponent is going to be. For now, that's all we're going to go into that. And so the last one kind of demonstrates our property that we started with. So if we're going to have a over b times c over d, we can write that as one fraction, a times c over b times d, the result, the product. And we don't have to write with the multiplication symbol. We can just say AC over BD, and we are done. We know that means multiplication. All right, so we've got 3 different expressions down here, and we want to show that they're all equivalent to 5x over 3. So I'm telling you, these are all equivalent to this. So I have 4 different expressions, including this one. And they're all equivalent. They're all the same. So we want to prove, why are they all the same? So if we're going to go and take this one, we're actually multiplying 5/3 times x. Well, anytime we multiply times a whole number or a single variable, it's just like if it's over 1. So really, this is like it's 5 over 3 times x over 1. And if I multiplied that straight across, it's 5 times x over 3 times 1. And we can start to skip this middle step. So the top is 5x and the bottom is 3, just like this. So I can write 5/3 x, or I can write 5x over 3. They mean the exact same thing. What about this one? 1/3 times 5x, is that equivalent? Well, kind of the same strategy we had here. If I'm multiplying times 5x, it's like multiplying times 5x over 1. And according to our properties, we're just going straight across. So the top is 1 times 5x, and the bottom is 3 times 1. And so when I go ahead and multiply that out, 1 times 5x is 5x, 3 times 1 is 3. And sure enough, I get the same thing. So I need to know that this is equivalent to this, which is also equivalent to this. So 5/3 x is the same as 1/3 times 5x, which is the same as 5x over 3. And what about this one? Well, now it's basically just putting the 5 on this side. So is 5 times x over 3 the same as all of these? Well, 5 is the same as 5 over 1. And if you times it by x over 3 and you follow our properties, 5 times x over 1 times 3 is 5x over 3. So by showing all this work, I've proven that all 4 of these expressions here are equivalent. They're all the same. They're all equal. So if I plugged in the same number for x in all 4 of these expressions, they would produce the same outcome. All right, let's flip it over. We'll go to example number 3. So here's where we start to get into the more serious stuff. We're going to start simplifying these where it's not just a fraction. There's algebra in it. There's variables. So first of all, let's deal with the numerical part of it, the numbers. If you had the fraction 5 over 10, think about what you would do with it. You would hopefully get it down to 1/2. So you're dividing both of them by 5, and you end up with a 1 on top, and you end up with a 2 on the bottom. But now we got to deal with the variables. And just like if I had a 5 on top and a 5 on the bottom, they would both kind of reduce down to 1 over 1 or cancel in a way. The same thing's going to happen here with the b's. So a b over a b is just 1 over 1, which we don't have to write. So basically they cancel. So what am I left with? I'm left with a 1 times an a on top, and I'm left with just the number 2 on the bottom. And so I should simplify this. 1 times a is just a over 2. So 5ab over 10b simplifies down to a over 2. How about 27x squared over 9x squared? So dealing with the coefficients first, 27 and 9, I can divide those by 9, and it's 3 and 1. And now I've got x squared and x squared. Now, what do those actually mean? X squared is x times x, and this x squared is x times x. So right now I have 3 times x, and I have 1 times x. So these two x's cancel, and these two x's cancel, leaving me just 3 over 1, which is just 3. So if you have x squared over x squared, you don't have to write it all the way out like this. And x squared will cancel another x squared. Okay, 2 over 2 is the same as 1, so we have 1 and a 1. The two y's here will cancel each other out, and I still have a z. So right now I have a 1 on top, and then I have a 1 times a z on the bottom. I don't need to write 1 times z, so my fully simplified version still has to have the 1 on top. You can't get rid of that. But on the bottom, I'm just going to have a z. So if we have a 1 in our denominator, we know that it is not necessary to write it. So 3 over 1, we can just write 3. But if we have a 1 over z, we can't just write z. It's different. Z over 1 would be z, but 1 over z, we have to leave it there. It's a fraction. That'd be like saying 1/2 is the same as 2, because you're like, well, there's a 1 there, so it equals 2. Well, no, that's not true. Okay, so you can't just drop that top part and write the bottom. All right, 48CD over 6AC. Dealing with these first. So let's divide by 6. So we're going to get an 8 on the top and a 1 on the bottom. I have a C on the top and the bottom. Let's cancel those out. So what are we left with? I'm left with A times D on the top and 1 times A on the bottom. So an 8 times a D is just 8D. I don't need the multiplication there. And a 1 times A, I don't need the multiplication, and I don't even need the 1. And so I'm just going to leave the A right there on the bottom. That's fully simplified. Now 12 and 18, those can be simplified by 6. So I get a 2 and a 3. I divided them by 6. Now I have an m squared and an m. Those don't cancel each other out. An m squared is an m times an m. So if I wrote this out now, what do I have left? It's 2 times m times m. That was from the m squared. And on the bottom, I have 3m. So this m will cancel this one, but I still have an m remaining. So it's 2m over 3 as my final answer. So when you come back up here, when we want to start skipping this middle step eventually, we need to know m squared is like 2m's, and this is just 1. So what I like to do is I'll cross out the 2 and I'll cross this out, but I still have this m. So I treat this like, okay, it's no longer m squared, it's just m, and this m goes away on the bottom. So you can do it that way, or you can write it out for now as m times m and just cancel 1, whatever works for you. All right, so what happens when we're multiplying two of these big algebraic fractions? Well, there's two things that you can do. You can multiply straight across and simplify later, just like with our numerical fractions, or you can simplify first and then multiply. And I think you're going to like this one better once you see it, but both will work. So if we're going to multiply first, okay, we're going to do the whole top here. So it's going to be 4x times 3y, and on the bottom it's going to be 27y times 2x squared. So if we actually run the math there, can't multiply an x and a y, they're just going to tag along, but 4 times 3 is 12. So you're going to write 12xy. And on the bottom, 27 times 2, that's 54. And I got an x squared and a y, and they just go together. So notice they don't become like xy to the third or something like that. You don't combine them, they stay separate. So if it was an x squared times an x, then that's x to the third. But different letters, you can't put them together and start increasing the exponent or anything like that. So an xy multiplied is just xy. All right, now we want to simplify this. So I've got 12 and 54. Let's divide those by 2. So if I divide those by 2, I'm going to get a 6 and a 27. So let's see what we've got left at this point. We've got 6xy on the top, and on the bottom we have 27, and let's write this x squared out as x times y. So let's think about what can cancel here. Well, oops, this is a y. What can cancel here? So the y's can cancel. That's what I was starting to do there. The y's can cancel. They're gone. And since I had an x squared on the bottom, that means I actually have two x's. So one of them will cancel with the x that's on top. Plus, this 6 and 27, if you see it, you can divide these by 3 at this point. So let's write what we did here. We divided by 2. So here we're going to divide by 3. So 3 goes into 6 2 times. 3 goes into 27 9 times. So now we've kind of made a mess here. What's left over? We've got just a 2. Everything else has gone away on top. We've got a 9 on the bottom, and we still have one of these x's from the x squared left over. So here's my final answer. Okay, that kind of seems like a lot of work, right? And it's kind of like I always talked about when we were multiplying just numbers and we didn't have these variables here yet, is that before you multiply fractions, you can kind of simplify some things early, and it'll save you kind of a whole bunch of simplifying with bigger numbers later. Same thing applies here. So we're going to do the same exact problem, but we're going to simplify first. So when you look at these individual fractions, 4 and 27 don't simplify, 3 and 2 don't simplify, x and y don't simplify, y and x squared don't simplify. But when we're multiplying, we can understand that it's going to end up looking like this. And so we can actually start to cancel things early across the fractions. Now, the reason you're allowed to do that is because we're going to write it like this. And once it's all in the same fraction, the 3 and the 27 cancel, the 4 and the 2 cancel, the x and the x squared partially cancel, and the y's cancel. But instead of rewriting it, we can do it right here. Okay, so 4 and 2, divide those by 2, and you're going to get 2 over 1. 3 and 27, divide those by 3, and you're going to get 1 and 9. You've got x and x squared, so this x is going to cancel one of these x squareds. So you have an x, and y are going to cancel. So I've done all this simplifying and canceling early. Multiply straight across. 2 times 1 is 2. 9 times 1 is 9. And this x canceled one of these two x's, but we still have one left over. And I got to the same result a whole lot faster and easier than this top part. So this is what we want to start moving towards. It's being able to simplify early, understanding that when we multiply these two, it can be written as one big fraction. So because of that, we can simplify these numbers before we start actually combining them through multiplication. So we're going to cross simplify, you could call it, and get rid of everything before, and it'll save us a whole bunch of time.